Hello, AS students. Okay, I'm going to go through the chemistry mock exam that you took a couple of weeks ago. Right, so first section, multiple choice, question 1. I don't really think there's a quick way you can do this, other than very quickly write down the atomic number and add or take away the number of electrons. Okay, and then that tells you which one is different to the others. This one, composition by mass, empirical formula. Best way to do it really, I think, is just to quickly scribble it out so that you can see it's 2 to 5 to 1. Number 3, I'm not sure that the answer given in the mark scheme is correct. The mark scheme says B, but I actually think it's A, because any gas takes up the same volume, in the sense of 1 mole takes up the same volume. So obviously, if we've got 0.4 moles, we would expect this to take a higher volume than 0.3 moles. But I'm going to speak to Susie about that and see what she thinks. Okay, question 4, smallest atom economy. So, you know, this is the formula for atom economy. Products are, of this particular equation. You can see there are more products here, so it's kind of an educated guess in a way to go for that one, because the more products you've got, the smaller the atom economy will be, because you divide the required product by all the products, the molar mass of all the products. So, you know, these are all water and hydrogen, so yeah, you've got that extra CO2 in there, so I think you can go for that one fairly confidently. Okay, you're asked here to calculate percentage uncertainty, and the main thing to remember is that if you're taking a burette reading, you'll be reading it twice. So you take your uncertainty, divide it by your titer, which in this case is 19.95, 24.95 minus 5, but you need to multiply your answer by 2. Okay, which element has atoms with the greatest number of singly occupied orbitals? Okay, so we've got carbon, which has used 2p orbitals, yeah, and they will be filled singly. If you look at the others, then you'll see that you've got paired electrons. Polar molecule, this is the only one it could be, because it's not symmetrical. These are all symmetrical, even though they've got chlorine, obviously, which is electronegative in them. They are symmetrical molecules, so the dipole is balanced out, cancels it. They all cancel each other out. Okay, it's only if they add together that they create a polar bond. Okay. Highest melting point. You look at the structures there. You've got 3 simple molecules, 1 giant covalent structure. Boiling points for the halogens going down the group. Obviously, you bear in mind that if you're looking at the halogens, you are only looking at London forces, because they are elements on the periodic table, so there's not going to be any difference in electronegativity. Yeah, these, you just need to know these tests, don't you? That if we add concentrated ammonia to iodide, brown white chloride, then the one that is insoluble is the iodide. Okay, the increase in temperature here would be the same, because the reaction is the same, basically. Okay, right, so we're given an equation and asked for to work out which element is oxidized. So we can see that phosphorus has been oxidized and reduced. So basically you've got to work out which one. Well, actually you don't need to work it out. You can see that there's disproportionation. Phosphorus is both, so it's got to be phosphorus, isn't it? And then you're given 3 substances here and asked which one or which of these substances experience induced dipole-dipole or London forces. Okay, so SiO2 is a giant covalent structure, so it's only going to be the molecules. All molecules experience London forces, yeah? Even if it's added to some other force. Okay, section B. Let's have a quick look. Question 1. Alright, we've got a definition here which should be straightforward. You know, the electrostatic attraction between oppositely charged ions. You have to learn it. A number of you didn't get that right. Dot and cross diagram to show the bonding in barium oxide. Okay, so this is actually the representation of the bonding, where you have the positively charged particle, the negatively charged particle, and the attraction between them creates that what we call the ionic bond. If you wanted to show the formation of the ions, that's fine, but it didn't get you any extra marks in this case. Important thing is to show that 2 electrons have come from the barium by using a different symbol. So I've used dots for the oxygen electrons and crosses for the barium electrons. Right, calculate number of barium ions in 1.5 grams of barium oxide. The formula for barium oxide is BaO, so it's a 1-to-1 ratio of barium ions, yeah, in this compound. So if we know the moles of barium oxide, we'll know the moles of barium. So basically we work out our moles and then we multiply by Avogadro's number, or Avogadro's constant, to give us the number of ions. Okay, we're looking at electrical conductivities of solid and aqueous barium chloride. Some of you were talking about molten barium chloride, which is not the same thing. Obviously, molten barium chloride is when you have the compound and you heat it up to the extent that it melts. Aqueous barium chloride means it's dissolved in water. So be careful with your terminology, it's absolutely crucial. And a lot of you talked about moving electrons, and I stressed in the class, and I'm stressing yet again, that in an ionic substance, electrons do not carry electricity. It is the mobile ions, and it's pretty straightforward that in your solid barium chloride you have no mobile ions. In aqueous barium chloride you have mobile ions that can carry electricity. Okay. Barium chloride is used to test for a sulfate, and a white precipitate is formed, and again that's something that you just have to learn. If you hadn't learned your tests, then difficult to get those 2 marks. Okay, so we're asked to calculate X here. This is a hydrated substance. You're given the molar mass, asked to work out what X is, how many water crystallization molecules there are. So we've got work out the molar mass of barium chloride without the water, yeah? Which tells us basically that we've got 36 molar mass of 36 of water, which tells us, divide by 18 tells us there are 2 waters. Yeah. So as I said, you work out your anhydrous barium chloride, which you're just adding up the molar masses. You take that away from your hydrated, and that tells you how much water is left. Yeah, nitride ion is the N3 minus, so that means it's got 3 extra electrons. So you look up nitrogen, which is 14. So 14. It's 7. Sorry. and add 3 electrons is 10. Okay. Reacts with water, write an equation including state symbols for the reaction. So that's important that you have the state symbols in there, and that you identified, it says forming an alkaline solution, it's going to be barium hydroxide, and an alkaline gas. You've got nitrogen in there, it's going to be ammonia. Okay. Right, okay, so this is using the ideal gas equation, asking you for the molar mass of an alkene, which, you know, is kind of irrelevant. The fact that it's asking for an alkene, it's just asking you for, it's giving you some information, asking you to work out the molar mass of it. If you rearrange the equation for a number of moles, important thing is to make sure that you change the units of cubic centimeters and kilopascals. Kelvin is fine. So you work out the number of moles, and then you can work out your MR from that. Yeah, because you're given a mass here, and you've got the number of moles, so you can work out the molar mass. Okay, question 3. Number of atoms in a certain mass of europium. Important to read the question in terms of your answer must be given in standard form and to an appropriate number of significant figures. So you can see here that this is, the question is written to 2 significant figures, so your answer will be to 2 significant figures. So work out number of moles from the mass and multiply by Avogadro's constant to work out how many atoms there are in that number of moles. Okay, complete the table, and I was surprised that a few of you got this wrong. You know, europium, it tells you the atomic number is 63, so it's going to be that number of protons. The number of electrons in a neutral atom would match the number of protons, but this is 3+, so it's lost 3 electrons. And obviously, because this is europium-153, take away 63 to give 90 neutrons. Now this is really basic stuff that, you know, you would have done at GCSE, let alone right back in September at the beginning of this course. We would have reviewed it then. So please, if you got this wrong, ask yourself, did I do enough looking at the basic chemistry? I don't know how many students got this right, maybe 2 out of about 27. Okay, the 3p orbital only has up to 2 electrons. S orbital, 2 electrons. Any p orbital, any d orbital, 2 electrons. If not the 3p subshell. 3p subshell has 6. Yeah, okay. And then the third shell is made up of S, P and D. So the total number of electrons that could be in that shell could be 18. Okay, so we're given some electronegativity data. To be fair, some of you may not have known how to draw methanol, although you are given the formula, CH3OH. And this is a question about hydrogen bonding. So I'm not sure that you shouldn't have been able to work out how to draw it if you weren't sure what to do. CH3OH on the end tells you very specifically, yeah, put in your partial charges to show the 2 most polar bonds in methanol, which are going to be between the carbon, the oxygen, and the hydrogen and the oxygen. I don't know, some of you were sticking charges out here on the hydrogen, which doesn't really make sense because the oxygen is pulling electrons towards it to give it that delta minus. So it's going to make the carbon positive and this hydrogen positive, slightly positive. Obviously the water molecule you should know. Both lone pairs, says show all lone pairs, and then label the most important intermolecular bond between them. So, you know, don't forget this has to go from a lone pair on the oxygen to the hydrogen. And oxygen here has 2 lone pairs. A number of you only put 1, so you can't get the mark for it. Okay, this is a carboxylic acid, which again shouldn't put you off. You were given a sheet to tell you which the alkyl group was, in case you didn't know that. So this is your alkyl group. And then you're just looking at, don't forget you are looking at a given atom and how many bonding pairs or lone pairs there are around it to recognise the shape and the angle. So it says around a carbon atom in the alkyl group. So both of these carbon atoms have got 4 bonded pairs around them. Tetrahedral shape, 109.5. You need to know it, you need to learn them. The reason that they take up that shape is that they repel each other and they're as far away from each other as they can be, and that happens to be at an angle of 109.5. And then suggest a value for the COH bond angle in propanoic acid, COH. So you can see it's got that kind of bent or non-linear shape. Its oxygen is going to have 2 lone pairs, so you're going to lose 5 degrees effectively, 2.5 for each lone pair, so 104.5. Okay, question 6. So you're given some data on abundance of isotopes, okay, and it tells you the percentage abundance of magnesium, +1 ions of magnesium, and then asks you to complete the table of protons, neutrons and electrons. Yeah, so magnesium is on the periodic table, so you can find the number of protons from the atomic number. The neutrons will be the mass number minus the atomic number, which is here, and they are +1 ions, so they've all lost 1 electron. So normally the electrons would be 12, they've all lost 1, so it's 11. And to calculate relative atomic mass, a percentage abundance times the mass number, yeah, or the MZ ratio, but just think of it as mass number, divided by 100, and then it asks you to give your answer to 2 decimal places. That's very important. If you didn't do that, you lost a mark. Okay, you're given some information here about substances B and C, and you're told that they both have an approximate molar mass of 140 grams per mole. Okay, and then you're asked to identify them. So be methodical, look at B, then look at C. So we add acid to B and it gives bubbles, which indicates carbonate, and there is no change to C. Addition of barium chloride to C produces a white precipitate, which indicates a sulfate, and no change to B. So we know, a carbonate and a sulfate. It tells you that they are group 1 elements and that they've got roughly 140 grams per mole. So you know that. If they're group 1, just go down and kind of see. If you know it's a carbonate, add them up. This one, it's not going to be less than potassium. And if you look at the next one down, rubidium, that's much too heavy. So it has to be potassium carbonate and sodium sulfate. But if you didn't refer to the molar mass, it's in the question. And the fact that it's in the question means that, it's there for a reason. And you need to refer to it to come up with your answer. Then, you probably only maybe got 2 marks here. At most, maybe 3. You couldn't get all of the marks if you didn't refer to that molar mass. Ionization energies for elements across period 3. Okay, so you're asked to add a point for the first ionization energy of the element with Z equals 10. Now this is, as you go down a group, ionization energy decreases, and that applies to any group. Z equals 10 is the noble gases, so it's neon. So it has to be higher than this value here, 1,500. Anywhere above 1,500 would get you that mark. And then estimate the energy required to form one sodium ion from 1 sodium atom. So here, this is ionization energy to form a 1 plus ion is kilojoules per mole, okay, per mole. So we're trying to find one atom. So 1 mole of Na plus ion is 500 kilojoules per mole, yeah? Therefore, if it's 1 sodium ion, you're going to have to divide it by Avogadro's constant, okay? Because, obviously, in 1 mole, that's how many sodium atoms or sodium ions there are, okay? Why do they show a general increase across period 3? Because nuclear charge is increasing, but shielding remains the same. This results in a stronger attraction between the nucleus and the electrons, which decreases the atomic radius. Okay, straightforward stuff. Why does the general increase in first ionization energies across period 3 not be followed by magnesium and aluminium? And this is down to orbitals. Magnesium is S block, aluminium is P block, and therefore you've got the electron is in a higher energy orbital for aluminium. Okay, this is about acids and bases. So the question is about an acid and a weak acid. So if you didn't answer both parts of the question, you didn't get the mark. Definition of an acid is a proton donor, and a weak acid doesn't fully dissociate, and they are definitions you need to know. Reacts with ethanoic acid, yeah, and you had to balance the equation. Pretty straightforward. Look at which element is oxidized and which has been reduced, and the oxidation changes to numbers. So obviously we've got 2 elements here, so 0 and 0, so we know what we're looking at. Hydrogen is always +1 unless it's in a hydride, and it isn't here, it's just in an acid, so +1 to 0, which means it's been reduced. And aluminium has gone from 0 to +3. You know it's +3 because that CH3COO, and there are 3 of them, is the minus ion effectively from the acid. Yeah, it's lost its hydrogen, hasn't it? So that's negatively charged as such. So you know it's +3. Okay, titration here of ethanoic acid, is it? Yeah, vinegar or ethanoic acid. Yeah, so you're given all the information. You're told that it reacts with barium hydroxide. You're given a volume and a concentration for that, and you're told how much ethanoic or vinegar reacted with it. You're given a volume, but obviously not a concentration. We're asked to work out the concentration. So this is just a straightforward titration calculation. Other than at the top here, it tells you 10 cubic centimetres was taken from the bottle initially and made up to 250 cubic centimetres. Okay, so you have to remember that you're going to have to come back to calculate the original concentration from that original vinegar. So number of moles of barium hydroxide you can work out because you're given the information. You look at the ratio in the equation. There's 2 to 1. So you multiply, so you know how many moles of ethanoic acid there were in 25.45 cubic centimetres. So moles per dm cubed in the diluted vinegar after it had been diluted. Yeah. So then you need to convert it back to the original vinegar. So you take your number of moles that you've worked out times 250 over 10. Because you took 10 cubic centimetres and made it up to 250 cubic centimetres. Okay. And then finally, you're just asked to suggest an assumption that's been made, and I put the obvious one that there is only ethanoic acid in vinegar. May have other acids as well, which would have reacted too. So there's an assumption made that that's all there is. And if that was the case, the concentration of ethanoic acid would be less than the result shown if there were different acids in the vinegar. Okay, bit of a marathon, nearly 25 minutes of feedback there, but you can go through them question by question. Don't have to sit and watch it for 25 minutes. Just think of me sitting here having to do all this talking. Right, see you later. Bye.